Custom subnetting. Well, I'll tell you what, in custom subnetting, a lot of people get frustrated with it if they've tried to learn it from somebody that didn't really know how to explain it well, or if they just tried to do some self-study on it and they just didn't quite grasp it. That was the case with me years ago when I was first learning this, because my mind is not mathematical by nature. I was an English major, so I have a hard time with math. And in fact, I can't even balance my checkbook unless I'm using Quicken or something like that. Well, don't let the math intimidate you, especially if you're not geared that way. For those of you that are geared that way, this is going to be a breeze for you. In any case, we'll try to make it a breeze for everybody in custom subnetting, and we'll start by calculating the number of hosts that you have or that you need by using the calculator, again, our handy little friend, the calculator, and we can use the same calculator to calculate the number of subnets that you might need as well. And then the hard part comes in. It's not really that hard, but the more complicated part comes in the subnet bits and calculating which bits you need for the subnetting. And this is where a lot of people have gotten confused and try to think through this so hard that they start bleeding out the ears and stuff like that. So we'll try to make that simple for you, and we'll also take a look at the subnet IDs that you can get as a result of the subnet bits that you've calculated. Then we'll also take a look at the host ranges that you can use in each one of your subnet IDs. And this whole nugget here is mostly going to be just working through a series of exercises. I have some Word documents here that we'll work through some tables, and we'll have to come up with certain scenarios and things and how to figure out getting what we need. And I'll also put up both a blank form of those up on nuggetlab.com for you, as well as all of the answers that you will be seeing within this nugget. In addition to that, I'm going to put up an exercise sheet for you, if you will, so that you can kind of work through some on your own and try to see if you're getting this down, as well as an answer sheet so that you can check your answers. Let's go ahead and talk now about custom subnetting, and this is where we will divide up our network address range so that we can get a more practical use of the number of hosts compared to the number of networks. So, for example, if we're on a Class B network, how many hosts do we have available to us? Remember? Well, we got about 65,000 hosts available to us, which we're not going to want to use on a single network. So we'll want to divide that up. Now, if you've had somebody explain subnetting to you in the past, maybe your best friend tried to explain it to you, but he wasn't a very good trainer, and now by the time you're done, you're more confused than you were when you got started. Or you tried to learn through some kind of self-help thing on the internet. Or you took those self-hypnosis tapes and you listened to those or something like that, and you tried to learn how to custom subnet mask. Well, chances are you don't know any more about it now than you did when you got started, or at least you don't know the whole picture. I'm going to try to explain this to you in such a way that you're not going to want to stick a fork in your eye out of frustration by the time we're done. So to do that, let's go ahead and take a look at some IP addressing questions that I've got here, and this will be scenarios in which we have a given network ID, like this class. What class is this? Class A, B, or C? Class B network ID, and it's got a default subnet mask of what? 255.255.0.0, and we're going to say to ourselves, you know what, we got 65,000 hosts given this range because we got these two last bits that can be used for hosts. We don't need that many hosts on a network. And we want to break this up into more manageable pieces. So how are we going to do that? We're going to be doing that with custom subnet masking, which we'll take a look at here using these various exercises. Also, I'll put these as well up on nuggetlab.com, as well as some other exercises for yourself that you can use to practice with. And I'll also have the answers up there for you, just in case you weren't able to come to the proper conclusions. Now, the key to begin with here is to go back to the calculator. Remember, the calculator is your friend. You always trust the calculator. And that is to take a look at how you can determine how many hosts are available and how many networks are available. Now, remember, I said just a moment ago, the last 2 bits are reserved for host. And in binary, that would be 8 bits here on the last, and 8 bits here on this one. So that gives us a total of how many bits? 16 bits. You can use the calculator then to confirm how many hosts we have available with this default Class B network address. And you do that by using the power of function here. So that would be this button here, the X caret Y thing, whatever you want to call that. So that would be 2 to the, and how many bits do we have available? 16. So 2 to the 16 equals 65,536 hosts. Now, there is a rule that states that you cannot use all ones for a host ID or all zeros for a host ID. The all zeros is used to designate or to identify the network ID, and the all ones is used as a broadcast address in most networks, so we will remove those 2 possibilities. So you can't use all zeros, can't use all ones. That means that we would be left actually with 65,536 minus 2, which would be 65,534 possible host IDs or host addresses. So now then, returning back to my original exercise here, I don't want to use all of these bits for the host IDs because that's going to be too many, 65,000. Instead I want 4,900. Now the question is, what I want to do is to borrow host IDs and give them over to the network, which would give me fewer host IDs that are available then. And what I can do with that then is to go to something like this, where I'll now steal host bits and give them over to the network side. Because remember, originally we had our dividing line between network IDs and host up here. Now we're shifting that over to the right progressively to give ourselves fewer hosts available, but we're conversely giving ourselves more networks that are available. Now, how do you know how far over here to go? Do I stop here? Do I stop here? Do I stop over here? How do I know how many host bits to steal to give to the network? What you can do then is to go back to your original question here. I've got 4,900 that I need to use. And let me give you a quick shortcut with this. You just add 4,901, and put that number in decimal into the calculator, 4,901. Then convert that to binary, and that gives us how many bits here? 4, 8, 12, 13 bits. Don't be concerned about whether they're zeros or ones. All we're doing is counting the number of bit positions that are available here. Now that we know that that number is 13, we can go back into our binary thinking here, and we can say, here, how many bits do I have? There's 8, 9, 10, 11, 12, 13. Okay, I've got 13 positions available for my hosts. And that means that I'm now going to change my subnet mask, so it's now not a default subnet mask, but it's now a custom subnet mask, which starts off always still with a 255.255 for Class B. But now this is my custom part of it. This is my subnet ID. And this will be 255.255.224 if I add 128 plus 64 plus 32 together. And for clarity here, I've added in another line here. My network ID still stops here because that's my default subnet mask, but I've added in an additional component to this, my subnet mask, or my subnet ID here, and that's these first 3 bit positions, and then I still have my remaining hosts over here. Now, the next question that comes up is, how many subnets did I need? Because but with the default subnet mask, remember, I've just got one network. Well, I want at least 5 in my original exercise, if I remember right. Yeah, 5 subnets. Now, here, we just do the opposite of what we did to configure the number of subnet hosts. Remember, we added 1 to that number and entered that into the calculator and converted to binary. Here, we're going to still start with decimal, but we're going to subtract 1 from the minimum subnets required. So let's put in 4 instead of 5. So we'll put in 4 in decimal, and then convert that to binary. That gives us 3 bit positions. That's not 100, because we're in binary. That's a 1, a 0, 0. And all we care about is the fact that that is 3 bit positions. And you always have to do both, because you might not have the appropriate range to give yourself both 4,900 hosts and 5 subnets if it's in some other class, or there's something that won't work out with math with that. So always calculate for both of those numbers so you can make sure you're going to get what you need. In this case, the answer came up that I would need 3 subnets, 3 subnet IDs here, so that works out just fine. That's what my answer was. I used 3 bit positions. Now, the next thing for us to figure out here is, besides what our custom subnet mask is, and I'll just put that in here, and I'll just kind of shorthand it. Here we've got 255.255, our default class B, plus our custom subnet, right here, custom subnet mask of 224. And then here I've just put it in kind of a combination of binary and decimal. Here I'm just shorthanding with decimal. And then here's our binary part that we're concerned about, because this is where we need to do our calculation. And then all zeros at the end, of course. Now, what I want to figure out here is, although I know I'm meeting at least my minimum requirements for the number of hosts and subnets, how do I know exactly how many hosts I could get per subnet? What if we had growth and we went past 4,900? How many could I put on that network? 7,000? 10,000? How many could go? Well, we still go to the number of host IDs. That was 13 of them there, so I'll go into calculator, and I'll go into 2 to the 13, equals 8,192 minus 2, because you can't use all zeros, and my mouse pointer's goofed up here, but you can't use all zeros, and you can't use all ones for the host ID. So that would be the maximum amount I could use, 8,190. Well, it looks like I've got that solved for the host per subnet. I've even got some room for growth there with up to 8,000 per network. But how about the maximum number of subnets that I could use? Well, I've got 3 bit positions used here, so again, I'm going to use calculator for that. 2 to the 3 equals 8, so I'll put 8 down here. That's the maximum number of subnets that I could use. Now, you might have looked at custom subnetting in the past and someone told you, oh, well, you also have to subtract 2 from the number of subnets. So someone might say, actually, that can only be 6. Hold on a second. That was true a long time ago. I mean, like back in 1995 or something like that. Because in 1995, Cisco came out with RFC 1812, which allows routers to be able to use all ones or all zeros in a custom subnet ID here. So you don't have to subtract for all ones and all zeros like you do for the host side, and you still have to do that for the host side. That's why we came up with 8,190. But on the subnet ID, you can still use all ones or all zeros there, so you don't have to subtract 2. You can still go to 8 unless your routers are pretty old and they're being held together with baling wire and duct tape or something like that, then you should be able to use the maximum number without subtracting 2. Now let me show you another interesting correlation here, and that is how the number of masked bits here will cut in half the number of hosts that we can use. For example, right now I'm using the first 3 bits for networking. If I decided to steal yet another bit and make myself 4 ones there instead, then how would I know how many hosts per subnet that would be? Well, remember that we're originally 8,192 before we subtract our 2. Every time you steal an additional host bit, then just cut the number in half. So if I were to use 4 bits there, then my number there would actually be 4,096. And then I would have to subtract 2, and it'd be 4,094 in reality. Then if I were to steal another bit, every time you move to the right and steal an additional bit, it cuts your number in half. This would then give me 2,048, and if I were to steal another bit, keep moving my way over to the right, then it would be 1,024, and so on all the way down the line here. Now, you don't need to memorize that. I'm just telling you that as kind of a tip, so that if you're looking at this and you're thinking, okay, right now I've got, 3 masked bits here. What would happen if I wanted to steal another one? Would I still have enough hosts per subnet and that kind of thing? If you can just kind of do calculations in your head by having the number, every time you steal an additional bit, having whatever number you have, then that's a quick and easy way to calculate that, even without using the calculator. Now, another thing we need to do then is we need to figure out what our subnet IDs are going to be. And this will be address ranges that are available per subnet. So now I've got 8 subnets. I can't just use any IP address in this entire network ID for any of those. Because I'm custom subnetting, I'm going to be limited to a certain range within each subnet. And the way we figure that out is we take a look at the last bit that we used for our custom subnet mask. What position is that? There's 128, 64, 32. Okay, that's the 32-bit position. This tells me that my subnet IDs are going to be divided in parts of 32. So I'm going to start off with my first one, and by the way, the first subnet ID you use is always the one that you already assigned, so I'm just going to put that same exact number right down here, so 172.25.0.0, and then I'm going to increment that by 32. Again, how do I know it's 32? Because that's the last bit position that's used by the custom subnet mask. So now it's going to be 172, if I can type, 172.25.32.0, and then I'll just fill all the rest of these in. And so here I've just gone ahead and filled all the rest of these in so that you can see them. And then on each individual physical segment within my network, I would use one of these ranges. For example, the first physical segment would use the 172.25.0.0, but would only work up to 172.25.32.0. Actually, it would be one behind that, and I'll show you that in just a moment. So on each one of my physical segments, on one segment I'll use this range, on another segment I'll use this range, on another segment I'll use this range, and so on down through the line. Now let's go ahead and take a look at our host ID ranges. Then I'll put all of this together in an example for you to see how one particular subnet, or a couple of subnets perhaps, would look if I used the custom subnet mask that we're using with these subnet IDs and with the ranges that these will yield. Now with my subnet host ID ranges, they're going to be based on my subnet IDs. Now, before we get to those host ID ranges, however, let me also point out that this last range, this last subnet ID that we have available ends in 224.0, and that would be something that you can also use to kind of give yourself a guideline as you're coming up with your subnet IDs. The first one is whatever your original subnet ID is, which was 172.25.0.0. I already mentioned that. The last one will be equivalent to our custom subnet mask in the subnetted position. So 172.25.224 here, 224 here, same number, .0 for our last subnet ID. Now, let's get back to our host ID ranges. That all starts with the same subnet ID that you've already got listed here. So my first range that I could use on my first subnet would be 172.25. And then I have to figure out what my first IP address would be. And for that, I've just pasted in a binary equivalent here for our network ID, which is 172.25, and that covers our default Class B network portion of our address space. And then this covers our subnet ID portion. Now for this, for the actual addressing, we can use all zeros or all ones for this part of the address, remember. That's why we don't have to subtract 2 from the number 8 anymore, because with current networking equipment, we don't have to do that anymore. And then for our host IDs, remember, we cannot use all zeros or all ones. So here I'm going to do the very lowest number I can use. That's to all zeros except for the last bit, which would be a 1. And then the last address that I would be able to use would be all ones and then a 0 in this last highlighted position here. So if I convert all of this now to a decimal equivalent, what do I get? I get 172.25.0.1. That's the first IP address I can use on the first subnet ID on the first physical segment within my network. And then what's the last one I can use in that same range? That would go up to 172.25. And then here's what you do. You just look at your next subnet ID, that's 32.0, and you back off 1 bit from that. So to back off 1 bit from that, I would switch this then to all ones and then a 0 as I discussed previously. And if we convert that using our calculator, or if you can kind of do this in your head at this point, then you'll see that this equivocates to 31.254. Let me give you another tip here, by the way. If you want to be able to just look at this and say, I can just kind of tell instinctively that that's 31, here's what you do. Notice that these are all a series of single ones right here in all these bit positions. This is going to be one less number than the next bit over. So this is my 32-bit position. And if this is all ones are turned on, then that's just one number less. That would be 31. So 32 here, all of these turned on, that means I'm at 31. So anyway, that would be then 31 dot, and then all of these turned on except for the last one would be .254. And then you simply move up to your next subnet ID, so 172.25.32.1, and these will all be .1s. In fact, what I'll usually do is I'll just fill in all the first ones like this. So I'll just go to the next one, 125.64.1, and I'll just kind of fill these in real quick as long as I'm in the same space on the chart. And so here I've just pasted in all of the rest of these, and then you just fill in the range to the rest of them, 172.25 dot, and then I'm going to go to one number behind 64.0 here, and that would be 63.254. And then the next one would be a similar idea, 172.25.64.1 through 172.25 dot, not going up to 96, I'm going to 95.254. You just fill in that same method all the way down through the rest of this chart. And so then I filled in all the rest of these, and notice that they all stop one short of the next subnet ID. So for example, with this 127, that stops short of 128. 128 through 159 stops short of the next range, which is 160.1 through 191.254, stops short of 192, up through 223, which stops short of 224, and up through the end of our available address space. And if we again look at that last IP address in binary, where I filled it in right here, we see that indeed we have our 172.25 dot, and then for our host position, remember, we can use all ones and then a 0 for our last, oops, if I can get my mouse straight, for our last bits for the host. Now, remember, this is our subnet ID where we can use all ones, so that when we do this in the decimal equivalent, we're going to add all of these up together, which would give us our 255 here in our decimal, and then our last decimal equivalent here would give us 254 in the last bit, or rather the last octet. Okay, so that gives us an idea of how all of this works. Now let's go ahead and take a look at how this might look in a physical network. Now here we've got a network ID of 172.25.0.0, two networks that we're dividing up here with this router in the middle. And our first subnet ID, remember, is always going to match our actual network ID, so it's 172.25.0.0. And then the first available IP address, all zeros and then a 1, would be 172.25.0.1. And I just assigned that to the router interface, which is common. But you don't have to, but that's what I did here. Then also, I put the last available IP address within this subnet ID, which is 172.25.31.254 on the server right here. And this is our custom subnet mask, 255.255.224.0. So then I can fill in any address between 0 and 1 and 30 to 31.254. I can fill in that in with any other host that I had on this subnet. Now on my next subnet, I'm going to increment, remember, by 32 for this next subnet ID, and therefore my first subnet IP address in this subnet ID would be 172.25.32.1, and my last one would be 172.25.63.254, again using our same custom subnet mask. Now, the custom subnet mask that you determine to use for your network ID here to divide up into various subnet IDs will always be the same. I'm not going to have 224 on this subnet and then 248 on this subnet or anything like that. I mean, I could, but it wouldn't be very good network design. Now let me also point something else out here. In binary, I've put up here an IP address for one of the addresses within my host range. Here I've got, actually let me put it in decimal so you can see it, 172.25. And then for this one, I've got an 8 plus a 2, so that would be .10.0. Now a lot of people that would look at that will say, that doesn't look like a valid IP address. That looks more like a network ID or a subnet ID or something like that. In reality, you could assign one of your hosts this IP address because it is an IP address. Look, over here, remember that's my subnet bits right there. These are my host IP bits, my host bits over here. They're not all zeros. They're not all ones. I've got a 1 and a 1 right there. So this is a valid IP address, and I could use that on a host. Now in the next exercise we have a Class A address of 10.0.0.0 with at least 70,000 hosts per subnet and 100 subnets. So to figure out, let's just go with the number of subnets required. That would be 100 minus 1 is 99 is what I put into the calculator here. So that would be 99 in binary would be 7 bits. So I'll put in my first octet, which is my 255 for a default Class A address. Remember, we always keep our classful subnet first. And then my custom subnet mask would have to be 7 bits. And then the remainder would be all of my host ID. So what would that give us? That would give us a decimal subnet mask, custom subnet mask of 255.254.0.0 for our custom subnet mask. And I also want to double check to make sure that I can get 70,000 hosts out of these bits over here. So I can go back to my handy little calculator, 70,000 and 1. Remember, we add 1 to the number of hosts that we need and convert that to binary. And that gives me a lot of bits. 16 plus 1, that's 17. And that's exactly what I have here, 17 bits for the host side. So we're okay on that side. Now then, exactly how many hosts will that get me per subnet? So that was 17. So that's 2 to the 17 minus 2. You go back to the calculator, go back to decimal, 2 to the 17 equals 131,070 because we're going to minus 2 there. So 131,070. And I'll put a comma in there to make it more readable. And that's how many hosts we can get per subnet with 17 bits reserved for the host. All right, now how many subnets can I get if I divide this network ID using our custom subnet mask here? Well, that gives me 7 bits in the custom subnet mask, so I'm going to go 2 to the 7, and I don't have to minus 2 there, remember, so 2 to the 7 equals 128 networks. So 128, that gives me more than enough to meet my requirement there. Now let's go ahead and go look at our subnet IDs as well. Notice that our last bit in our custom subnet mask is in the 2 position. This one is a 1 position, this one is in our 2 position, this one's in our 4 position, so forth. The last one we're actually using for a custom subnet mask is in the 2 position. So we're going to increment in numbers of 2. So that would be our 10.0.0.0 would be our first subnet ID. The next one in increments of 2 would be 10.2.0.0. Next would be 10.4.0.0, 10.6.0.0, 10.8, and you get the idea here, .0.0, and then I'm just going to put in a few dashes here to represent, and so on and so forth. And then we'll go down here, and then let's do our last 2, would also be in increments of 2 there, 10.252.0.0 and 10.254.0.0. And this line here is actually a page break, so just be aware of that. Just don't be confused by that line there. And now then I went ahead and put a hard character tern in to make this all appear on one page. Now, in our host ID ranges, we start off with, in our first subnet ID, all zeros and then a 1, conclude with all 1s and then a 0 at the end there, until we move on to our next subnet ID of 10.2, and we do the same thing all over again, 128 times, and I just kind of filled in with my so on and so forth line there, and then we conclude with, at the maximum, 10.255.255.254, which is all 1s and then a 0 at the end. Now, you might be looking at this and saying, wow, James, that's still a lot of addresses. I've got 131,000 hosts times 128 on 128 different subnets. What can I do with that? Well, if you're an ISP, for example, you might take one of these subnet IDs. Let's say we take 10.8.0.0, and I might further divide that. I might sell it off to somebody or lease it off to somebody else, and I would say, I'm going to call this a Class B address. Let's show you how I do this. This really goes a bit beyond our scope. But it's kind of an interesting thing to look at. It's good exercise in what we're doing here as well. Here I'll just say I've got a 10.8.0.0 that I'm going to sell to a client, and I'm going to give them this subnet mask of 255.255. In other words, that's a default Class B subnet mask with a Class A addressing scheme. Now, for the client, they should consider this to be all Class B. They're not going to treat this like a Class A. It's going to be treated like a Class B, which means that if they want to subnet that further to give themselves 800 hosts per network and give themselves 50 subnets, then they're going to need to subnet this third octet right here, and just the same way as if they were going to subnet a default Class B address that they'd been given. Now remember also that this is a private IP address in the 10 dot range, so I wouldn't really sell that off because after all, it's already free to anybody that wants it. But I might do it for another subdivision within my own organization or something like that. And in order to calculate all of this, again, let's go to our subnet host and go back to our calculator. I need 801, excuse me, 801, guess I better type that in right, 801. And I'm going to convert that to binary. That means I need 10 bit positions for my hosts. And then for the subnets that I have, I need 50 minus 1, that's 49, so I'm going to go up here in decimal again. 49 in binary would be 6 bit positions. So then that would be a custom subnet mask of 255.255 because that's what's already been assigned as a Class B addressing scheme. And then our third octet, which we're custom subnetting here, we would give ourselves 6 bit positions. So that would equivocate to see if I can do this in my head. 252.0. Okay, so 255.255.252.0. And if we look at that in the binary, it'll be 255.255.1234567 And that's what it would look like in terms of our custom subnet mask, kind of combining the shorthand of decimal with the longhand of binary here to get a good view of what we're actually working with here. And then for the maximum hosts per subnet, how many would that be? Well, I'm just going to fill this in here, but if you want to check me with a calculator, feel welcome. The hosts per subnet, I'm going to have 8, 9, 10. 2 to the 10 minus 2 would be 1,024 minus 2, so that would be 1,022. And then how many subnets can I get out of this? Well, that's going to be, how many positions do I have there? 6. So 2 to the 6 would be 64. And then the subnet IDs would be incremented in terms of 4. Because remember, our last bit position for our custom subnet mask is in the 4-bit position. So that would be my first subnet ID would be 10.8.0.0. My second subnet ID would be 4 more than that, 10.8.4.0, 10.8.12.0, and so forth. And then I just filled in all the rest here up to 252, which remember, your last subnet ID is equivalent to your subnet mask, your custom subnet mask, so I know I have to stop at 252 there. And then here I just increment by 4 also in the host ID ranges, and all zeros and then a 1, and then all ones and then a 0 for my range of IP addresses. And I see I made a little boo-boo in here, so I'm missing the .8.0 here, so that should be 10.8.8.0, because remember we're incrementing by 4s, so 4, 8, 12, and so on and so forth. Alright, now let's move on down to a Class C, which we haven't done yet. And this is going to be important not only because, well, let's just get some experience in subnetting it through all of these different ones, and now we're in Class C, but also because this has a little bit of a trick to it that I'll show you as well. And it's something you really got to look out for because it can turn around and bite you. Let's first of all look at working with our custom subnet mask. We need 13 subnets, so let's just go to calculator here, and 13 minus 1 is 12 in decimal, so we go to the binary thing. We need to have 4 bits for our custom subnet mask. So our default is 255.255.255.0 is what it would have been, but we're custom subnet masking, reserving 4 bits. That should be 240, so that would be our custom subnet mask in this case, and that would be in binary equivalent to 255.255.255.111134. Okay, that's what our subnet mask would look like in the shorthand and in the binary of the custom subnet mask for this last portion. Now then, how many hosts per subnet? Well, we only got 4 bits reserved for our hosts now, so we're going to be pretty thin on this, but we don't need too many. So let's go ahead and go to this. How many hosts can we get? We can go 2 to the 4 equals, and that's 16 minus 2, so we can actually get 14 hosts per subnet, and then the maximum number of subnets we can get was really the same math, 2 to the 4, only we don't have to minus 2, so we'll stick with 16 on that one. Then for our subnet IDs, we've got a 192.168.56.0, because remember that's the same as your original network ID. Then the next one would be 192.168.56. And how far do we increment on this one? Well, what's our bit position of the last stolen bit over here? It is in the 1, 2, 4, 8, 16 bit position, so we're going to increment by 16s on this. And then you go 192.168.56.32 and 48 and so forth. Now let's also take a look at our host ID ranges. Now we'll use the same method here, although it might look a little bit different initially. We go 192.168.1, that's our first available IP address, through 192.168.56. And then we have to carefully calculate what's in that final bit because it's not going to be very obvious in decimal what's going on there. 192.168.56. And if we're masking the first 4 bits for the subnet ID, then if we're going to go to a 15 there, for example, that would be this. That would be a 1 plus a 2 plus a 4 plus an 8 would be 15. Well, remember that I cannot have all 1s in the host address, so in the host portion, so I can't use that. Instead, I'll have to back off a 1 and put a 0 in the last position there and make this instead a 14. Then for my next item, normally we would just increment this. Our next one would be 16. At least that's what it looks like in the previous examples we had, but we can't do that either because 192.168.56.16 would look like this. And that once again leaves us with all zeros in the host portion of this IP address. Well, we can't have that, so we'll have to back that off and give it a 1 there instead. And that would mean that our first address in this next subnet would actually be 17. And then we'd have to go through the same thing all the way on down through. Now then, if you look at this, these all do actually increment by 16. It's just that we can't start with a 0 here because we can't have all zeros in this IP address here. So we start with 1 plus 16 is 17, plus 16 is 33, plus 16 is 49. So it all follows. You just have to look at it a little bit differently and always be mindful of not having all zeros or ones in any of the host ID range. And if you want shortcuts also on the last bit in each available range, you can start off with 16 and then subtract 2 to 14. And then add 16 to that is 30. Add 16 to that is 46. Add 16 to that, 62. So it does increment by 16. It just doesn't look like it initially. And then, of course, the last host ID range we would have here would be 192.168.56.241 up through 192.168.56.254. In this nugget, we took a look at custom subnetting, and we saw how, ooh, that was a crooked line. Anyway, we saw how that you can use the calculator to calculate the number of host bits that you want to have, and the number of host bits that are going to be available when you wind up with your custom subnet mask, as well as the number of subnets that you want to have, or the number of subnets that will be available once you come up with your custom subnet mask. And your custom subnet mask is really a series of subnet mask bits, which might be 1110000. 0, 0. Is that enough zeros? Okay, yeah, there's my 8 bits. So maybe it's something like 224 here. Then once you figure out your subnet, your custom subnet mask, then you take a look at the furthermost right item there, which is a 32 in binary, and that's how we'll divide up our subnet IDs in sequences of 32. So it might be, 0 to 31, and then 32 to 63, and then 64 to 95, and then 96, and so forth and so forth. And we do that all in increments of 32. Now, once you figure out your subnet IDs, then you need to identify the first and last IP addresses in the host ranges, and we took a look at that as well. The key thing there to look for is that you don't want to use all zeros or all ones in the host portion of your address. I hope this has been informative for you, and I'd like to thank you for viewing.